All right, good morning, everybody. So, for today, we are going to continue talking about lesson 6.1. So, this is the second half, starting off with example number 3, where we are practicing our parent functions, of course, and all the transformations that can happen. So, let's recap what we saw just right before example number 3 here. What we were talking about was this concept of a vertical stretch and a vertical shrink. So, it says, uh, I'm only gonna multiply the letter y, right? All my y coordinates by whatever factor they give me. If that number is between 0 and 1, then I'm gonna have a vertical shrink where the graph is gonna get wider. And if I have a number that is bigger than 1, then we're gonna create a vertical stretch, which means it's gonna get a little more narrow, whereas some people say, oh, get the function gets a little skinnier, if that's the case. So that's why when we saw this problem, we see that the number 2 is bigger than 1. And if the number 2 is bigger than 1, then we're going to have a vertical stretch by 2. And then look at what we did. We took every single y value and multiplied it by a value of 2. Here's what we get after our multiplication. And when we drew our points, look at that. We have that more narrow, right? Or that purple one is skinnier than the original parent function. And so that's what we're doing here. We're practicing our vertical stretch and our vertical shrink. So let's get started with the next one. So for problem B here is my function called h of x. Remember, that's just a name. We have an x squared. But remember, for a parent function, we're not supposed to have any coefficients, any numbers. We don't deal with negatives. That's why for this problem here, slide it over there, our parent function, we can say is that this is a quadratic. The reason it's a quadratic is we see that power of 2, of course. And because it's a quadratic, our parent function is y is equal to x squared. So we're going to bring up the points that come with that. Here's my x, here's my y. The classic 3 points are negative 1, 1, 0, 0, 1, 1. So we're going to start off with these points here, throw them in our graph. So here we go. We're going to plot them. And we're going to draw just a small little version of it. So there is the quadratic function. And we're going to call it y is equal to x squared. It's just the parent. It's not my final answer yet. So now looking at the problem closer, we know there's a number involved here. And anytime we see a number, we have to question what it does to the graph. Now, it's not in a parenthesis, so no, I'm not going to move left and right. It's also not, it is outside, but it's not adding or subtracting. So this isn't going to be a vertical translation. As soon as we see the number right in front of the function, and we see that it's between 0 and 1, look, a 1/2 is between 0 and 1, then it's what we saw here. This is going to be a vertical shrink because it's between the numbers 0 and 1. So all I have to do is I have to write down that this is a vertical shrink. And we always have to say by how much. So we're going to say by 1/2. Now, that's great and all. That's a great description. We have it written down. But now we actually have to do the work to create the shrink for this parent function. Well, remember what we said yesterday. In order for me to create the shrink, all I have to do is multiply all of my y values by 1/2. So I'm just going to multiply everybody by 1/2. And I'm going to create my brand new numbers. Look, so here's my new table. And in my new table, we have a negative 1, a 0, and a 1, of course, because we're not messing with our x's. We're only changing our y values. So 1 times 1/2 is just 1/2. 0 times 1/2 is still 0. And again, 1 times 1/2 is just 1/2. And for those who struggle with, oh, I never liked drawing or graphing with fractions, well, here we go, eyes up. Negative 1.5. So that means negative 1, and then you only go halfway up. You know you can't go a full block. That'd be too much. And so 0, 0, and 1 to the right and halfway up. Remember, we said this thing was going to get wider. So when I start to connect my dot, see, there it is. Look, it's wider than the parent. And that's the one that we can officially call h of x. So the Helen or the Hector function, right? So there it is. Remember, these are the 3 things that we want to be able to do with the parent function when it comes to transformations. These are the three things we need to see on every homework problem as well: the parent, the new function, and its description. So let's practice a little bit more. Yeah, there's a couple you tries, but we will do them together. We are doing the exact same thing they asked us to do. We're going to graph each function and its parent and then describe the transformation. So it's the same thing that we've been doing for every single problem. So here we go again. To locate the parent, yeah, this is my y value. Yeah, here's the x. Remember the 1/2, numbers do not belong with the parent. So that means the parent function here is the absolute value. Remember, we need to throw an equation at you, and you should be able to tell me what kind of function it is. We see those little lines. That's what makes it an absolute value function. These little lines right here. But now let's talk about the points that all parent absolute value functions go through. The basic three: -1, +1, 0, 0, +1, +1. Remember, an absolute value gives me positive results every time. So -1, 1, 0, 0, 1, 1. There go my points. And we're going to try to draw the lines as best as we can here. So use a straight edge. Anything that'll help you make straight lines. Looks nice and neat there. So this is the function called y equals the absolute value of x. That's just the parent, nothing else. So now we're going to look at what they gave us. What else they said? So they gave us a 1/2 in front. Well, it's very similar to the problem we just did, but I wanted to show you how it also looks different, even with an absolute value here. So the 1/2, it is less than 1, like we mentioned earlier in the previous problem. So this is a vertical shrink. But it is a vertical shrink by a factor of 1/2. So just like we did earlier, I'm going to take every y value only and multiply it by 1/2. Every single one. And so now we're ready. We're going to create our brand new set of points here. So my new points, let's see, x and y. Still -1, still 0, still 1. But my new numbers are 1 times 1/2 is just 1/2. 0 times 1/2 is 0. 1 times 1/2 is 1/2. So you see the same numbers we just got earlier. So it should make the graphing a little bit easier, right? Look at that. Same numbers I started you off with before. The only difference, we're not drawing a parabola. We are drawing the absolute value. And notice how it got wider. Notice the difference, or at least the similarities, with what we drew with the quadratic, and then here, the fact that it got wider than it was before. And this is the one we call g of x. This is what our final answer looks like. So again, they want three things: the parent, the function, and the description. But again, we have to be able to look at an equation and say, I know what this equation looks like. And then we have to know what every number does to that function. So look at number 5. Looking at number 5, once again here, we see that power of 2. So right off the bat, we should know exactly what kind of function this is. This is a quadratic function. So the parent is the quadratic. That's the family it's related to. And when it's a quadratic, we know that because of the power of 2, this is what the parent would look like. Which is why, just like all other parent quadratic functions, well, there's really only one, it goes through -1, 0, 1, and my values are 1, 0, 1 again. Look at that, very similar to the absolute value, because just like an absolute value, a power 2 only gives me positive results. We're going to plot the points, but remember, this time it's a quadratic, so got to give it that little curve here, and another little curve right there, so something like that. Y is equal to x squared. There's the parent. Now, we see a 3. We know that 3 is having an effect on our graph somehow. So when I look at that 3, then the question is, okay, well, it's on the outside, so it's not up side to side. There's no plus or minus, so there's no up and down. This right here is either a stretch or a shrink. But because this number is bigger than 1, then we know that this is a vertical stretch by a factor of 3. And then the question is, well, how do I do the actual stretch? Well, then it's what we said earlier. I multiply only my y values by 3. So the only mistake so far the students have made is they'll make this statement and then they say, well, I don't know how to do it. Well, you need to write out your points then so that you can see it. Because now if I have this, well, then I'm ready for my graph here. I'll make my new little table if we need it, which is -1, 0, 1. And look at your new numbers. 3, 0, 3 again. So -1, but up 3, 0, 0 again, and then 1, 3. Remember, when you do a stretch, the graph compared to the parent is more narrow. Or, like I said, as some students sometimes say, it got skinnier than the original. So now, again, this is how we should be handling shrinks and stretches. As soon as we see a number in the front, we know multiplication has to happen to your y value. So it helps if you actually write your table down, especially if this is new to you. So now let's look at our last page. In our last page, we've kind of just been doing one thing at a time. We did stretching, we did translations, we did reflections. Well, what happens when they just throw it all into the mix together? So last thing we're going to do is we're going to talk about a combination of transformations. And all it says is you can use more than one transformation to change the graph of a function. And then notice, they want us to do the same thing. They want me to graph g of x, they want me to draw the parent function, and they want me to describe the transformation. So it's the same thing we've been doing in every single problem. So first thing I want to do, let's find out who the parent function is for this graph right here. Remember, to find the parent function, there's my y, there's the x, but nothing else can get highlighted. Parent functions don't have any addition or subtraction or any negatives involved. That's why my parent function is clearly, because of these lines, the parent function is the absolute value, which is y is equal to the absolute value of x. Now I'm going to write my points just in case we need them. I don't think so, but look, it doesn't hurt. It doesn't take long either. 0, 0, 1, 1. It's the same points, and I'm just going to draw them, plot them on my graph, and then I'm just going to connect the dots because they did ask for me to draw the parent function. So we're going to do a little quick sketch of our parent function. So there it is. Y is equal to absolute value of x. That's our parent. Always label your function so that you know which one it is you're working with. All right. Now it's time to break this thing down even further. So when we're breaking this one down, remember what we said. We're going to go in order from left to right. Everything has an effect on the graph. So first thing I see is a negative in front. All right, well, according to our word one, according to our notes, as soon as that -1 is in front, that's not a stretch or a shrink because it's not an actual number. It's just a negative value. But that negative right there is telling me to do one thing and one thing only. And that is, I need to do a reflection across the x-axis. So that's step number one. We're going to take care of this first. So I want to do that first right away. I don't want to mix it up with any of the other rules. So a reflection across the x-axis. So that means if my points are right here, here's the x-axis, just to give it some color there. I'm going to flip this graph over. So the point one, -1, 1 is now going to be -1, -1. 0, 0 stays. It's on the axis of symmetry, reflection. And then 1, 1 is now at 1, -1. Now I'm not going to draw this too dark because technically this is only part of it, right? We haven't actually done everything they want me to do to it. In fact, if I was going to write something, this is just the negative of the absolute value of x, but nobody else. That's it. That's all we've done so far. Now, once we have this one, these are my 3 new points. So the question is, well, what else do they want me to do with it? Well, we also see here that they have a 5 right there. Now, the 5 is inside the parentheses, and so we've said before, if you're inside the parentheses, this is when we move side to side. But when we move side to side, this is when we think opposite. So that positive 5 in there just means we're going to go to the left. We got to think opposite, 5 spaces. So again, that's what that 5 is doing for us. We're going to go left 5. And then we have this 3. Looking at this 3 over here, yes, it's on the outside. It's not inside the absolute value. So because it's on the outside, this is telling me that I'm going to move every single point I have. I'm going to translate it down 3 spaces. Now, these 2 moves I can do together. It's very easy to do these 2 moves together. So we're definitely going to do that. So I'm going to handle this as my second phase of the problem. So here we go. Now, everything is moving 5 spaces to the left and 3 spaces down. Remember, we're talking about this orange one here that we left off on. So we're going 1, 2, 3, 4, 5. 1, 2, 3 down. There is the location of our very first brand new point right there. Now, you can do that to the rest, of course. But if you notice, the other 2 points they kind of form like a little triangle here. So we already know where those 2 points should be. But please feel free to count. Look, 5 over, 3 down. Over here, 5 over, 3 down. But anyways, the idea is we're pretty much done with this problem. As soon as I connect my dots, this is it. This is the final graph that they asked for. In fact, this is the graph that I can officially call, right? The given name was g of x. This is the graph that we call g of x. That's the final graph there that they wanted from us. So it does take some time, but be careful. It's all a breakdown. Everything you see creates something different or causes something to happen with our parent function, that original one we started off with. All right, last problem here of the day. Let's do one more example, and it says you try. We're just going to do it together first. So now we're graphing d of x. Remember, d of x, d is just a name. We could call this the David function, right? The Denise function. There's the y. Here's the x. But if you notice that x is surrounded by a power of 2. Now, powers I can highlight. That's part of the function. So that just means one thing. My parent function has to do with, there's that power of 2. It's a quadratic. So we're dealing with a quadratic function, and y is equal to x squared. So let me bring my points in. My classic 3, -1, power of 2 is 1, not 0. So 1, 0, 0, 1, 1. So we're going to do a quick draw. -1, 1, 0, 0, 1, 1. And then here comes our very happy looking parabola right there. Looks like a smiley face there. Okay, so there, the parent is done. But now we're going to break it down and see what every little value is doing to it. So the first value I notice is the number 3. Now, yes, the number 3 is outside the parentheses, but there's no plus or minus, which means this is either a stretch or a shrink. Well, because the number is bigger than 1, the rule is if it's bigger than 1, then we are going to do a vertical stretch by 3. Okay, so we're going to do a vertical stretch by 3. Now, what does that mean? Remember, how do we actually do stretching? We're going to multiply every y value by 3. So that's why it comes in handy sometimes to have that table drawn out for you. So then here comes our brand new table based off of this. -1, positive 3. 0, still 0. 1 and 3. We have our 3 points. So you know what? I'm going to draw this stretch now. There's 0, 0, 1, 3, and -1, 3. So there is our very narrow parabola, right? It looks like it got slender or skinnier, like I said before. So this is y is equal to 3x squared. Remember that green one, let's keep track, was the parent function, y equals x squared. But we know there's still a couple more moves they want me to do to this thing. I see a 5 there. So we know the 5 is going to do something to the graph. We also, of course, see that -1 here. So we know both of these are going to create something or cause something to this now orange graph that we have there. So let's see what it does. First of all, the 5. It says -5. All right, so let me bring that down here. Because it's in the parentheses, we do think opposite. So we're actually going to go to the right 5 spaces. Now remember, earlier I took care of the reflection first. I also did my stretching first. But when all you're going to do is translate, you can get both of those done at the same time. And so when it says -1, well, we're heading down 1 space as well. So we're going to take care of both of these things all at the same time. So this is going to be our second move for this problem. All right, so here we go. I'm going to move everything to the right 5 and down 1. All right, right 5. And we're talking about that orange one. So right 5, 1, 2, 3, 4, 5, and down 1. So here's that vertex for that parabola, right at 5, -1. And now remember, you can just move these 1, 2, 3, 4, 5, down 1, 1, 2, 3, 4, 5, and down 1. The other option was, look, you could go up 3 from the vertex and then go to 1 to each side. 1, 2, 3, 1 on each side. But anyways, here it is. Here is our very narrow parabola, which we can now officially call, right? This is what they wanted from us. They wanted us to draw d of x, the Denise or David function, whatever name we want to give it, right? That's all d of x represents. It's a name of the function. All right, so with that said, you should now have plenty of time. One, you need to log in to Google Classroom, go to my classwork tab, and of course, you should be trying the classwork 6.1 on quizzes. So the link is in Google Classroom under the classwork tab. Once you're done with that, and now you do need to get 100% on that classwork. So if you don't get 100% the first time, well, then retake it. It won't take you too long. It's just a review of everything we've done. In fact, you should maybe have your word wall out so that you can make sure that you do that quizzes very easily and you don't have to keep dipping back and forth through your notes. So here's what we have in our word wall here. It's a graph. That's what we're looking at there. So feel free, you can pause the video so that you can just stay here watching this and recording everything that's there. The other thing I want to mention is that as soon as you're done with that classwork, you need to finish Monday's homework and today's homework because all 3 things are your ticket out. You have plenty of time to work on it, check your answers, and drop it off in the box. Again, no excuse not to have all 3 assignments done because you have most of the period to finish. With that said, have a wonderful day, everybody, and then I'll see you again next time.